Hey guys, well, it's the last lesson for Unit 8. It's 8.4, the normal distribution. Our objective is that students will be able to use the normal distribution, or what's known as the bell curve, to answer given questions. Now, this is what we were talking about when we did the standard deviation, and we were talking about the mean and one standard deviation above, one standard deviation below. Now, this is our normal standard deviation curve, which is given to you on the reference sheet of the regions. Many large data sets have a distribution that can be described with what is known as the normal distribution, or something that's called the bell curve. This curve is seen in the accompanying handout that you have on the back as well of your paper. It shows the percent of a normal distribution that lies within half standard deviation increments. So notice in the bottom here, it starts with 0. This 0 is actually your mean. And then it goes up by 0.5. So one distribution would be all the way here. That's one distribution above and one distribution below. Each section, as you would like to call it, each section has its own percentage. So 0.0 to 0.5, that's 19.1%. So each section is labeled with a percent. From 0.5 to 1 is 15%. Now, just to understand this diagram, exercise 1. For a population that is normally distributed, find the percent of the following. Find the percent of the population that lies within one standard deviation. So remember, 0 is your starting, one standard deviation of the mean. So one standard deviation, it can be one standard deviation above, which is from -1 to 0, or it can be one standard deviation above, which is from +1 to 0. So this will be, for below, it will be 15 plus 19.1 plus 19.1 plus 15, which gives us a total of 68.2%. Now, what if it says within 2 standard deviation of the mean? So 2 standard deviation, I'm looking at -2, so it's from -2 to 0, and then above is from 2 to from 2 to 0. I will go ahead and add all of that. 4.4 plus 9.2 plus 15.0 plus 19.1 plus 19.1 plus 15 plus 9.2 plus 4.4. This will give me a total of 95.4%. Final answer. Now, and we will be referring to this diagram on numerous occasions in this lesson. More than 3 standard deviation from the mean. So more than 3 standard deviations. So something that has to be more than 3 standard deviation. If you look at where 3 is, it's right here. Let's get a different color. It's right here is 3. And then 3. So more than is anything that's, excuse me, anything that's this side or anything this way. So everything this way, notice where the percent is pointed. So it's 0.1 plus 0.1. So more than 3 standard deviation is 0.2. Now the last one says, what is the standard deviation between 1 and 2 standard deviation above the mean? So this is positive. So between 1 and 2, which is 9.2 plus 4.4, which is actually 13.6%. Okay, so I really want you to be able to understand this diagram. There's numerous questions that you need to know that's, on the regions for you to look at. Now, it can be easily seen from exercise 1 which we just did here, that the majority of the normal distribution population that lies within one standard deviation is the vast majority. So within one deviation, here was 6.82. A whole variety of problems can vary, as we know we're going to see here in exercise 2. Exercise 2. At Arlington High School, 424 juniors took the SATs. On the math portion, the mean was 540 and a standard deviation of 80. If the scores on the exam were normally distributed, answer the following questions. A. What is the percent of the math score that fell between 500 and 660? So we need to look at this bell curve again. But we need to know, how do we know where it is? Is it 0.5? Is it 2? Where is it? How many standard deviation above or below? So the way we calculate that is we take, we have to do it twice. For 500, we have the mean, which is 540, take away 500, and you divide it by the standard deviation. This works out to be, this is actually going to be 0.5 standard deviation below, and that's your keyword, below. How do I know it's below? Because 500 is actually below my mean. Now I need to do this for 660. So since 660 is higher, I'm going to start with 660, take away the 540, which is my mean, and I want to divide this by the standard deviation, and this is actually going to give me 1.5 standard deviation above. So I'm looking at 0.5 below and 1.5 above. Now what percent is that? I'm going to use my bell curve, and let me get my highlighter out. It says, what was it, guys? 0.5 below, which is up to here, and 1.5 above, which ends up to here. So it's this shaded section here, and I'm going to continue writing up here. You continue at the bottom. So for part A, what we're going to do is 19.1 plus 19.1 plus 15 plus 9.2, which will give me 62.4%. 62.4%. So 62.4% is the percent of math score that fell between 500 and a 600 range. So moving on to B. How many fell between 500 and 660? Round your answer to the nearest number. So what we need to know, there were how many juniors? How many juniors? 424. So I know from here it was 62.4% of the score. I want to know how many scores fell, how many students score between 500 and 660. So the way I do that is I take the 62.4% of the people that fell below, and I multiply it by the total number that we have, which is a 424. And of course, this will give you 264.576, but we can't have 0.576. This is actually rounded is 265 students. So again, this first part A is asking me for the percent of the score that fell between. Part B is asking me how many people score between 500 and 660. C is a little bit more application. It says if Evan scored a 740 on her math exam, what percent of the students who took the exam did better than her? So first of all, what standard deviation is 740? We know this is going to be above. It's higher than the mean, which is 540, divided by 80. Actually works out to be 2.5 standard deviation above. Okay? This is above the mean. Now, 2.5 standard deviation above. So let's go back to my standard deviation. First of all, let's get rid of all of this so we have a new fresh diagram to look at. And I want to get my highlighter out. She is actually 2.5. So the question asks, how many people did better than her? This is where she is. And people that did better than her are what I just highlight here. Just this little piece. She is right here. This is her cutoff point, 2.5. So the people that did better than her are actually 0.5 and 0.1, which is actually 0.6% of people score higher than her or him. It's a guy. Okay? Now it says approximately how many students did better than Evan. So we know it's 0.6%, but when we want to ask ourselves, what is 0.6% of 424? And that will work out to be 2.544, but we don't have a 2.5 student. So this is actually 3 students. So there were 3 students that did better than him. Okay? Now let's move it on. We have exercise 3. The height of 16-year-old teenager boys are normally distributed with a mean of 66 inches and a standard deviation of 3. For Jabari if Jabari is 72 inches tall, what is the closest to his height percentile? So, 72%, 72 inches. What's the mean? The mean is actually 66, so he's actually above. So 72 take away 66, divide by your standard deviation, which is 3, would give you 2 standard deviation above. So he is 2 standard deviation above. So we're going to go back and look at this bell curve. 2 standard deviation mean he's somewhere here. So he is in this percentile. Now, we can go ahead and add all of this, but the easiest way, since there are only 3 numbers here, we can go ahead and add these 3 numbers and take away from 100, because all of these add up to 100. So we can say that he is actually 100% take away the 1.7 plus 0.5 plus 0.1. And again, this is coming from here. He is at 2. So that means he falls between this percentile. Only this number of people are taller than him. So this actually works out to be 97.7%. Rounded, this is actually 98%, which is the 98th percentile. So again, this question is saying which of the following is closest to the height of the percentile for Jabari. He, as you can see from our normal distribution, he was at a 2. So he only had a few students or a few people that are taller than him. So I could have added all of this: 1.1, 0.5, 1.7, 4.4, 9.2, 15, 19.1, 19.1, 15, 9.2, and 4.4. When I round that, I will still get that answer. Now, exercise 4. The amount of soda in a standard can is normally distributed with a mean ounce of 12 and a standard deviation of 0.6. If 250 soda cans were pulled by a company to check the volume, how many would expect to have less than 11.1 ounces in their tin? Now think for a second. Standard deviation, the mean, and this is what's required. First of all, you ask yourself, is this going to be below or above? Exactly, this will be below because what I'm looking for is less than the mean. So this ends up being 12 take away 11.1 divided by the standard deviation, which works out to be 1.5 standard deviation below. Now 1.5 standard deviation, what is that? How many percent is that? Back to my standard deviation chart. Take this off. We're looking for 1.5 standard deviation below. This is my 1.5. Everything below is actually this way. So that works out to be 1.5 standard deviation below is actually 0.1 plus 0.5 plus 1.7 plus 4.4, which works out to be 6.7%. This is a 4. Just to be clear, this is a 4.4. So there are 6.7% that are below the 11.1. So here we know this is actually equivalent. We just found that to be 6.7% that are below or less than this 11.1 ounce. Now the question is asking you how many can is that? So I know it's 6.7% of 250 cans at survey, which is actually 16.75, which is rounded to 17 cans. Choice number 1. All right, so let's go. Exercise 5, our last example for today. Biologists are studying the weight of red king crabs in Alaska waters. They sample 16 crabs and compile their weights in pounds as shown below. Determine the mean and standard deviation of the sample. Round your statistical measure to the nearest tenth. So again, this is done, the mean and the standard deviation, and I'm using the sample. So go ahead, I'm going to put that in my calculator. I want to go to graphs, and then I want to enter these. 9.8, this is from the previous lesson. 11.1, 12.4. Make sure our numbers are correctly entered. 11.8, 13.2, 12.8. If you don't practice doing this and I'm just doing this and you're looking, you're not going to learn. You need to practice, make sure you know how to enter these numbers, know how to find the standard deviation on the calculator. 11.6, we're almost there. 13.4, 12.3. You can pause the video and enter them. You don't have to listen to me. That's perfectly fine. 14.2. Oh, this is 14.2. See, I said you have to be very careful. 15.1. Now you have all 16 sample. You go back to the top. Go to menu, statistics, stat calculation, choice 1. And then I want to do a one variable statistic, which is choice 1 again. Hit OK. Hit OK. Now looking at this, I'm being asked to find my mean, which is 12.5875, but I want to round that, so it's 12.6. And in my standard deviation, it's a sample population. This rounded to 1 decimal place is 1.5. So my mean is, we said, 12.6 pounds and 1.5 pounds. B said, why does the sample indicate that the population will be modeled using normal distribution? Hint, use your calculator to sort in ascending order. Now, first of all, why does it model in normal distribution? So the first thing we need to check, what is one standard deviation above and what's one standard deviation below? Standard deviation of x. This is actually 11.1. and this works out to be 14.1. The mean, add these two and then subtract it. So it says 11 of the data value including 11.1, so there are 11 of this that falls within one standard deviation, and as a percent it's 68.75, which is close to the expected value of what's given as a normal distribution. So there are actually 11 data values that falls within one standard deviation of the mean. Okay? Now it says, assume your mean and standard deviation of part A applied to normal distribution population crabs caught in Alaska. What is the percent that it will fall between 9.6 and 15.6 pounds? Now this is one of those we want to see calculate for both of them. So for 9.6, okay, that's 4. We know that this is actually going to be below our standard deviation because our mean is 12.6. So 12.6 take away 9.6, divide that by our mean, which we said was, what was our mean? Our mean was that 12.6 minus 9.6 divided by our standard deviation, which we found to be 1.5. This actually works out in your calculator to be 2 standard deviation below the mean. Now that that's below, we need to find out what is going on for 15.6. This is actually going to be above, so it's 15.6, take away 12.6, divided by my standard deviation, which is 1.5. This works out to also be 2 standard deviation above the mean because it's higher. The question is asking you what percent. So this is where you take, so we need to find what percent is 2 below and 2 above. Go back to here, and I want to find 2 below is at -2 and 2 above is at +2. So I want to find what's everything between here. What's all this percent added together? We actually did this calculation already in part B, which came up to 95.4%. But if, let's say we didn't do this, I will be adding all of these percent together. And that will go ahead and give me my answer as 95.4%. Now, the last part, which is D, if fishermen must throw back any crab caught between 10.4 pounds, approximately what percent of crabs caught will need it to be thrown back if the weight is normally distributed? So 10.4, remember my mean was 12.6, take away 10.4 divided by 1.5, my standard deviation. So this works out to be 1.4666 blah blah blah, which is approximately 1.5 standard deviation below. So anything that is that's below the 1.5 standard deviation, that's what we need to throw back. So back to my chart, take everything out, and I'm looking for 1.5 right here. So anything that's this side of it, below it, because that's what I'm looking, it's 1.5 below, is going to be thrown away. So which is going to be 1, 2, 3, 4 numbers that I needed to add. So if I want to find what percent is going to be thrown away, it's going to be the 0.1 plus the 0.5 plus the 1.7 plus the 4.4, which is actually 6.7% of the crabs caught is going to be thrown back into the ocean. Alright guys, so really important is, I know this is a short unit and today's video was extremely long, but thank you for your patience and being the scholar that you are and always willing to learn. Now come and see me if you have any questions before you start your study guide. Again guys, good luck and see you soon.